Hello everybody. So let us discuss how to graph trigonometric functions, right? So trigonometric graphing, trigonometric graphs, graphing, okay? So what we're going to do is we're going to graph the functions sine, cosine, okay? Then we're going to look into secant and cosecant, and then we're actually going to finalize with tangent and cotangent. And let me show you, there's a relationship between each of those. So first of all, let's recall the unit circle. Okay, unit circle. Before, what we have done is, remember, we got the common angles, and when we talk about going around in the angle from 0 degrees or 0 radians to 90 degrees, pi over 2 radians, to 180 degrees, right? 180 degrees is pi radians, and so on and so forth to 2 pi radians, or 360 degrees, and we go on and on and on around circles, right? The x value in the unit circle right there, that's what? That's the cosine. And the y value, that's the sine. So when we start at 0, right? What's 0 degrees? Cosine is the 1, the maximum to the right, and sine is the 0. There's no vertical, right? And then we go up, 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 up. The sine goes up from a 0 to a 1. The y goes up from 0 to 1 at 90 degrees. And cosine actually shrinks, so the x value goes from the rightmost 1 to all the way just back to 0, the x value, right? So it goes like that. As I rotate 90 degrees, it goes from 1 to 0. So let's look at that unit circle. Let's just remember how we do that. We set a circle. What is a circle of radius 1, right? That's what a unit circle is. And what is a circle? A circle is all points, a locus of points equidistant from the center. That center is not actually a point on the circle, but it tells us where it is located. And so let's take this radius 1. Here's a 1, 1, 1, 1. And let's draw a little circle. Again, a sketch circle here. That is going to be the unit circle. And all I want to help you remember is that if I have some angle, call it theta, this xy pair will be cosine theta, also equal to x is equal to cosine theta, and y will be the sine theta, okay? And remember, tangent is actually the sine over cosine of theta by the quotient inequality, trigonometric quotient inequality, which means when we divide sine over cosine, we get tangent, and that's going to be the y over the x. Turns out it's actually the slope of the line going through this origin. So the slope of this ray, let's say, looks like a positive one here. That will be the tangent of this angle theta. And we'll look into that in a little bit, okay? So we see the cosine and sine, that's the x and y. We would say, so cosine is my x value, sine is my y value. And we know, for example, this is a point, cosine of 0 is 1, sine of 0 is 0. We know this is a point where cosine of 0 is cosine of 90 degrees, is 0. Sine of the 90 degrees is a 1, right? And so on and so forth. We go around. And let's say if I did a 30 degrees, cosine would be root 3 over 2, right? And then sine would be 1/2 of the maximum up to the 1. Okay, so anyway, let me go ahead and begin graphing. Let's take this to be the y-axis, the axis for the function, and then this is going to be, let's say, the x-axis. A little neater here. So let's see, we will have let me make it a little more horizontal. So we will have this is my x-axis, okay? And so look at this. Let's call this angle x, and this is going to be maybe my sine of x. I'm going to graph in black the x versus sine of that, sine x versus x. So look at this. What are some important numbers, values in radians? Let's do this in radians. This angle as we go from left to right, right? It's actually going to be the angles increasing from 0 to, let's say, 90, which is in radians is what? Pi over 2. So let's do pi over 2 here. And maybe another 90, another pi over 2 to make it pi, 180 degrees. And then let's do 3 pi over 2, and let's do 2 pi, and so on and so forth, 5 pi over 2, right? We're going on. And then to the left, let's go negative 90 degrees, negative pi over 2, negative 180 degrees of pi, negative 270 degrees, and negative 3 pi over 2 in radians, negative 2 pi, and so on and so forth. By the way, this is going to be the period, and we'll see what I mean by that graphically. The period of this graph, the sine, because remember, every circle, everything begins to repeat itself. So we're going to circle, and then we're back in the same spot. And what matters in trigonometry, when you talk about unit circle, terminal side, any angle you're given, why do we find the coterminal angle, that angle in the 0 to 360 range, is because it's the position that matters. It's not where in the units, in the circle area, what quadrant and what's angle, the reference angle. That's what really matters to give us that trigonometric function, the exact value of it. Okay, so now, let's think about, well, on this graph, what would be my y-intercept? What would be, if I did 0, what's sine of 0? Right there, the sine of 0 is just a 0, right, the y value there. So I'll plot the point, 0, 0. Then I know at pi over 2, the 90 degrees, it goes up to a 1, right? So let's say this is actually the maximum we'll ever have for sine. So maybe this is a 1, and this is a negative 1. And at pi over 2, 90 degrees, sine of that is a 1. How does it go up here? Well, think about it. At pi over 4, half of it, it's going to be square root of 2 over 2, which is, let's see, about 0.7-ish, almost like 3/4. And right here about, and what about pi over 6? What is that? That's a third, so right here, 2/3 of the pi over, 2/3 of the pi over 4. So here we have a pi over 6 already, a 1/2. Sine of 30 degrees, pi over 6 radians, is 1/2. So right here we are with that. And so look, we go up, 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 up. Guess what? At this right here is going to be pi over 3. We know the common angles. We know pi over 3 is 60 degrees. The sine of that is root 3 over 2. That's about 1.7, 0.85-ish or 0.86-ish. So we're going to go up here, closer to the 1, and see what's going to happen is it's going to flatten out here. And again, think of it this way. The y value is going to quickly increase at small angles, right? And then all of a sudden, at angles close to 90 degrees, it's barely getting anywhere. Look. So we're going to the circle, and it's getting quickly bigger from 0 up, 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 all the way to 1/2, the y value. And then look, as I go around, it's about flat. It's flattening out, so it's getting a little bigger to 1, and slightly so, gradually so. So that's why it becomes kind of a gradual increase here. And then it's going to go back down. Think about it, pi, your y value right there, goes from 1 all the way down to 0 again in the same shape. So in the same setting, you can see it's going to happen to do that. Okay? And then you can see at 3 pi over 2 negative, which is 270 degrees, right? And then down there, it's a negative 1 for sine. So we have this, right? The negative 1 point for the 3 pi over 2. Okay? And we can then at 2 pi, it's going to be again back to the 0. And we will have this shape here. And you can try more numbers if you like to kind of give yourself more confidence that that's what's going to be happening. 5 pi over 2 is the same thing as 90 degrees. 450 degrees on the same location. Up there, where the sine is going to be a maximum of itself again, which is a 1. The range of this function, and you can see on the graph, it's negative 1 to 1, right? Between the y equals 1 line, you can even do that to the maximum, and then what is it? The y equals negative 1 horizontal line. Okay? So that's going to be the rightmost. Now, if I go negative direction, that's actually clockwise. That's going like this, right? Clockwise, and then go that way and that way and that way. So look, that's going from 0 height all the way to negative 1 height in the same shape. So at negative 90 degrees or negative pi over 2, it does this. Okay, so you see it's an odd function, actually, symmetric about the origin, or sometimes what I say to my students is, you flip it this way, about the y-axis, you flip it about the x-axis, and then if it's the same shape, then it was an odd function. Now, an even function is when you just rotate it about the y-axis, and all of a sudden it stays the same. We'll see the cosine will be an even function. So anyway, let's do this. Let's go back to negative pi. Well, negative 180 is also like a 180 location. And the sine of that is a 0. And so we go on, and we start repeating ourselves. This is why it's a wave. A negative 3 pi over 2 will be here. Negative 270 is like a 90. And you go on and on and on like that. Okay? There's our sine of x graph. And it takes a lot to initially feel this out, right? If you first time are hearing this, how to graph a sine graph, right? Let me see, it looks reasonable. Then, yeah, it's kind of, you have to put some emphasis, some time into this. Try to graph it maybe on your own, do some examples, and let's follow through with the next one. So let's now try to do the cosine graph. So cosine graph, that's going to be the x value. And now let me show you what's going to happen. Let's kind of go directly with a graph of this. So cosine of 0, well, that's the maximum, right, to the right, 1. So we have a point right here. Right here. That's I'm not going to intersect. I don't want to mess up the marker to intersect the black ink here. But there's going to be a point right there, 0, 1. So put a cosine of 0 is 1. And cosine of 90 degrees, pi over 2, that's going to be right there. That's going to be my 0, right, everyone? At pi over 2, 90, that's no x. X value is 0. It's vertical. And then it goes to -1 at pi. And then it goes back to a 0 at 270, 3 pi over 2. So look, it's always going to be 0 at every one of those pi over 2s, 3 pi over 2, pi over 2, 5 pi over 2 for cosine. So cosine is going to be in this purple color, okay, cosine of x. And we have, what will happen is actually from 1 to 0, it will decrease the x value. Look, so slowly it decreases, and then all of a sudden it's quickly going to 0. So now this is going to be kind of the reverse of what sine used to do. It will look like that, and then it will go down quickly to this 0 here at 90 degrees. Notice this spot right here. What is that point where they're intersecting? If you're interested in that, look, what you can do is you can say, well, when is sine of x equal to cosine of x? That's a trigonometric equation that we did in class earlier. Remember, what we do is we can, for example, let's divide everything by cosine. And so we get tangent x is equal to 1. What's the first such angle where tangent of x is equal to 1? Well, arctangent of 1 actually is 45 degrees, pi over 4. There's pi over 4. Uh-oh. That's why we have this intersection. And that height is going to be root 2 over 2, because sine and cosine are both, that's at that time, root 2 over 2. There's the intersection, hence there. And so if you go to, let's think about it this way. What if I do cosine of pi? Well, then it's a -1, right? And so we connect this way. And we continue. At 3 pi over 2, we already said that was going to be a 0 for cosine. And you see how much more quickly we can do this now. Cosine of 2 pi, well, that just goes back to the whole initial location of 0. And so we get a 1. Okay? And this is periodic. It has a period of 2 pi. Repeats. And then again, this is going to be pi over 4 from here to there. And it's going to intersect. Goes back to 0 here. So on and so forth. That's going to be my cosine graph on the right side. On the left side, I think about it, it's very much similar. You go from 1 to 0 this way. So we're going to go from 1 down to 0 at -90. Okay? And then guess what happens? We're going to go all the way to -1 when we have a -180. It's the same spot as a positive 180, right? So we're going to decrease from, what is it, -90 is right here, and that's a 0 all the way to -1. So from x is 0 to x is -1, right there. So 0x to -1x. And so we have, there we go, to -1x, here, -1. So I mean, in other words, cosine is -1, okay? And then 3 pi over 2, well, cosine is going to be a 0 again. You can try that. And you go here. And then -2 pi, it's just like a 2 pi, cosine is a 1. Okay? And so we go on and on. Now, somebody may be insightful enough to see something interesting here that happens. You see these graphs? You may wonder, well, are they exactly the same shape? Are they exactly the same shape? Are they maybe just is one shifted with respect to the other? And I'm looking at this and I'm thinking, well, is that the case? How about this? You see this purple graph and the black one, right? It looks like what happened is the black one is the purple one to the right by what? Pi over 2, right? We see this purple, this spot right here? It's a -pi over 2. This is a 0. This is a 0. This is a pi over 2, the corresponding points. So purple is a cosine. How would you shift a cosine to the right by pi over 2? Well, in other words, is sine of x equal to cosine of x shifted right by pi over 2? Well, what does it mean cosine x shifted right by pi over 2? Let's put it all together. This is actually, what does it mean to the right, shifted? It's x minus k, means you shift to the right by k. So cosine of x minus pi over 2 would be, that would be what we want to see. Is that sine actually equal to cosine of x minus pi over 2? Well, remember, what is my cosine of anything? Let's see, what's cosine of x, specifically x minus pi over 2? Well, guess what? Cosine of a negative angle, remember, is cosine of that same positive angle. You can just multiply inside the angle by negative, like cosine of 30 and cosine of negative 30, they're the same. They're both root 3 over 2, and so on. So this is actually equal to, you can just multiply that inside by negative 1, everything. So that cosine of x minus pi over 2 becomes cosine of pi over 2 minus x. Same sign, not negative cosine, but positive. And what does that mean, cosine pi over 2 minus x? There's a co-function identity that says cosine of that is exactly sine of x itself. So yes, indeed, sine of x, right, is this cosine x minus pi over 2, the cosine graph shifted to the left, sorry, to the right by pi over 2. Really cool, right? So that's a little proof of that. In other words, that they are exactly the same shapes, exactly the same wave, just shifted by 90 degrees to the right, or pi over 2, from this one to that one. Okay, so you may wonder, well, what about graphs cosecant and secant? Okay, and I want to do these also here with you, instead of drawing a new graph. It's very difficult to think for me in terms of to cosecant and secant, to think of them without thinking of cosine and sine. I always relate everything trigonometric first to sine and cosine. Those are the foundations for me. So when I think tangent, I think it's sine over cosine. When I think secant, I think 1 over cosine. Okay, let's try to do this the secant one. So secant of x is actually 1 over the cosine of x. We've done the cosine, it's a purple graph, right? What about secant? Well, it's 1 over that. You know what I'm going to do? Instead of thinking directly, oh, secant of 0, secant of pi over 2, what happens on the graph as you move around on the circle, unit circle? I'm going to do something else. I'm going to say, look, take a purple point, right there, 0, 1. What's 1 over 1? It's a 1. So in other words, here is a point. Green point is going to be, if it's a 1 for the purple graph, it's going to be a 1 for the green graph, secant x. Okay? What are other ones? Well, here, oh, by the way, so look at this one. This is also a 1 here, purple. So it's going to be a green. In other words, secant is going to be 1 at 2 pi. And yeah, we know secant of 0 and secant of 2 pi and secant of 4 pi and negative 2 pi, it's all 1. Because it's 1 over cosine of that, which is 1 over 1. And then actually, when cosine is a negative 1, let's say here, 1 over negative 1 is also a negative 1. 1 over negative 1 right there, wherever it would be, somewhere there, which is 3 pi, would also be a negative 1. And here, purple graph would go here, this negative 1. So you would get, again, this negative 1. And here, later on, you would have a negative 1. So look, we have these points. Now, when is cosine 0? What's 1 over 0? It's not, basically, it's not, we can say undefined, because 1 over 0, it will give you error in the calculator. And it's like infinity, but the question is, well, is it positive infinity or negative infinity? That's another tricky idea, because think about it. If you're talking about dividing by 0 or dividing by, let's say, a very, very small number, am I positive small? Above the x-axis, y-axis small, like above, am I positive? And then I'm dividing it by it to get what's 1 over very small. It's very big, we usually think. But what if it's a negative small, negative 0.00001? Then you're going to flip it to get a negative 1 million, right? So it's going down. So it's like a negative infinity. So it really depends. But look, cosine of here, look at this. These points here, there, the pi over 2s, there's 0. So 1 over 0, let's draw a vertical asymptote there, right? The vertical asymptote meaning you're dividing by 0. We're going to have some infinity behavior there. We're going to approach this green line vertically somehow. And then this one right here, look, we're dividing by 0 at that point. So we can draw these called vertical asymptotes, right? And there's another one right here. We're going to divide by 0 right there, pi over 2. So we actually, this is not going to be part of the domain. You cannot use these. Like if you actually put secant of pi over 2, you get an error in the calculator directly if you do that. Or it may say infinity, negative infinity, or something else, undefined, right? But look at this. Here's a 0. So 1 over cosine of 0 is what is it? It's undefined. We had this point, that's a 1. 1 over 1 is a 1, right? And then look, this is a 0, purple graph, 0 there, intersecting this x-intercept, so we have this vertical asymptote. Anyway, what happens is this, like, I always think of it this way, I tell my students. You take this purple graph and you flip it, because there's you're reciprocating it, dividing, secant is 1 over cosine. Think about it, 1 over 1 is 1. 1 over, let's say this is a half, becomes a 2, right? Let's say this is a half, it goes to 1, 2. 1 over a very small number is a very big number. 1 over, let's say root 2 over 2 is just a root 2, 1.4-ish. And it looks like this. It's going to increase to infinity up there. It's going to approach this vertical asymptote. To the left, it will do the same thing. You see the same flipping going on of the same type of graph, just going left. So you're going to do this. There we go. We have a big part. We already have half of the secant graph, of a period of a secant graph. Guess what's going to happen at the bottom here, the purple one? You flip it. That's what I'm going to tell you. I'm going to tell you that way. And it's not exactly a geometric flip, okay? It's not like I just take this piece and flip it, because of course this point would be, think about it, this is height 1, right? So I don't have this going to a 2. I actually have this as going to infinity. So it's very different than just flipping, directly. But the idea is there, and it looks like this, and then you take this purple piece and you flip it, but keep it inside these vertical asymptotes. And that's a good way, I think, to explain why this happens and why it looks the way that it does. These combinations of U-shapes flipping around, okay? And let's do this. And that you see is it's going to flip this negative small number, it goes to a negative large number. And by the way, notice secant and cosecant also, the range will be all the numbers outside of the negative 1 and 1. Because if you divide something between a negative 1 and 1, you'll never get a number actually smaller than a 1 and larger than a negative 1. So nothing here for the green graph. And it's actually going to continue like that. And nothing let's do the red one. Let's do the last one here, today, or this lecture here. The last one I want to do is cosecant of x. That's 1 over the sine. We're going to do the same flipping, but look, now my vertical asymptote will be right here at the 0, right? Because now we have the point, the x-intercept is here. So the black point, in other words, the sine graph, I'm going to flip it. Well, 1 over the 0 is a problem. It's an infinity thing, right? I'm going to try to keep it a little to the right, but otherwise it's really the same as the y-axis, as a vertical asymptote. At pi, you see that pi, what happens? We have sine of pi is 0, so cosecant of pi is undefined. It's an infinity plus or minus. In other words, it's we're dividing by 0. And here, we will divide, because this is, again, the black point there on his next intercept. We're going to have y equals 0. So sine is 0, so cosecant is 1 over the sine, 1 over 0. And we're going to have these problematic spots here, these vertical asymptotes. But they're going to help us a lot with allocating where this cosecant graph is. Okay? And so look, let's finalize this last graph. How? Let's see, where's sine 1? Where's sine negative 1, right? 1 over 1 is 1, so if you have a 1 here, we're going to have a 1 right there. You have a 1 again here for sine, you're going to have a 1 again there for cosecant. And then negative 1 for sine, right? There's a negative 1, because 1 over a negative 1, reciprocal of negative 1 is also a negative 1. And then here's a negative 1. So there's going to be a point, it's a big old kind of collection of points, but it's a point. I'm just trying to say this is red, these red are just points, and this is going to be a point here. Okay, red point. Okay, so now what happens is this, look. We're flipping the black graph very similar to cosine, right? We're now going to do this. Like, let's say half goes to 2, and you flip it and you do that. And you approach this asymptote here. You see it's a little different looking, right? I mean, it's very much the same shape as the cosecant and secant. We would expect them to be the same shape, because sine and cosine are the same shape. But they're shifted. And again, the cosecant is going to be this green one. The secant shifted to the right by pi over 2, very similarly to what we talked about with sine and cosine. And so now, here's going to be this one, right? It's going to do that, and it's going to do that. It's going to be more symmetric, of course. So it's going to look like this. Yep, like that. And then this is going to be like this. It's going to go on like that. And this, the U-shaped things, I guess, is what we can call them, like this, like this. And let's continue to draw more of these. Okay, and it's all symmetric. It's all hopefully making some sense here. There's nothing here red. There's nothing, this is what it is, okay? There are 4, initially, that I was going to do, 4 graphs, trigonometric, sine, cosine, secant, cosecant. Now, of course, there are cotangent and tangent, cotangent graphs that are slightly different. And let's see. Let me just give you a quick picture of how that would look, okay? So tangent is more like the y. Tangent of theta is a y over x. It's the idea of what? Sine over cosine. So it's equivalent to this idea of y over x, which is slope, okay? Equivalent to slope of this ray that forms this angle. So what we're going to do is, let me just tell you right now, at 0 degrees, let's say radians, tangent is just it's a flat line, tangent is 0, right? Because we have sine over cosine. Sine is 0, cosine is 1. 0 over 1 is 0. So tangent begins at 0. It rises up, the slope rises up all the way to infinity. It's a pi over 4, 45 degrees. We know its slope is 1. And so it goes from 0 to infinity when you go to 0 to 90 degrees. And so what it would look like, if I did a quick sketch, and I'm going to go into more detail on this later, but the tangent of theta versus theta, let's say, instead of x, okay, what happens is this. It starts at 0, and then at pi over 2, which is 90 degrees, right, it goes up to infinity. So we should probably have a vertical asymptote. And the reason we do is also why. Because cosine is 0 then, and 1 over 0, or sine is 1. Well, 1 over 0 is going to be infinity. So it does that, okay? And on the left, if I went negative angle all the way to negative 90 degrees, think what happens. Think what happens. And we'll see. If I go like this and I'm going negative, the slope is actually all negative. It's a negative. It's a 0, and then it's negative, 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 negative infinity. See this negative infinity slope right here? Okay. So what it does is it actually approaches a negative infinity. Okay. And then what happens when it passes 90 degrees? So infinite slope, all of a sudden it's a negative infinity. From positive infinity, it kind of jumps over to negative infinity. Negative infinity. Negative. It's like it's very steep, but now it's falling versus a rising. Okay, slope. And so we have a negative infinity. And when do we have 0 again? When is sine 0? Pi. Next one is pi. So pi, we have 0. And so we have tangent is also 0. And then it goes on similarly at 3 pi over 2, we have another problem. And so this is what tangent does. And so negative, what is it? Negative pi. And we do this. And you see that's how the beginning of tangent we could start kind of getting. And cotangent is a little different. Very much doing the same idea as we did for sine and cosine and cosecant and secant. Actually, cosecant, you know what we're going to do now? We're going to take, we're going to see what is my cotangent in terms of tangent. So what we're going to do is this. We're going to take cotangent, right? And I'm going to see in terms of tangent, what is it? So cotangent of theta is equal to, okay, well I know it's tangent of what? Pi over 2 minus theta. It's a cofunction, right? Identity. And then we have equals, let's see. Let's do minus, because it's a negative, this is an odd function tangent. Tangent of, let's flip the angle in there, tangent theta minus pi over 2, right? And guess what that is? That says it's a flip, negative is flip, when tangent is shifted to the right by pi over 2. So you move right by pi over 2, flip, and you flip it. Flip and right. Pi over 2. So that's kind of an idea I wanted to show you there, a little kind of demonstration, like symbolic notation. So look, we're going to take it to the right by pi over 2, and we're going to flip it. And what happens is these actually asymptotes are going to be taken to the right by pi over 2, so everything kind of shifts, right? This one and then this one. Let's see. Not there, but so this every 0 now becomes a vertical asymptote for this is cotangent. So we do cotangent purple. Okay, and then here, and what happens is the vertical asymptote is shifted to the right by pi over 2, okay, and we flip it. So now, instead of doing what this did, it's going to actually, and the infinity goes to 0 points, right? Cotangent of pi over 2 is actually 0, and it does look like this now. Okay, and the intersections you can guess, those are pi over 4s, 3 pi over 4s, and so on. And you can actually see that the period of this graph, okay, the period is actually of both of these graphs. It's pi. It's not 2 pi. It's pi because look in first and second quadrants. When you start first 180 degrees, first 90, and then 180, the slope goes from 0 to infinity, to negative infinity, back to 0, and then it starts repeating with positive 0 going to positive infinity, right? And then negative infinity all the way to 0. It just starts repeating when you go from here, first and second quadrant, to third and fourth. The slope kind of actually repeats. And so what happens is, that's why we have so many repetitions. Every pi, so the period is pi radians. And let's do this really quickly. Let's finish this up. Over here, and then we have like this, and like that for cotangent. One more period of that. So the purple one's cotangent, the black one is tangent, and hopefully that was a productive lesson, and you were able to grasp a little bit of how to graph this sine graph. Right? It's an odd function actually. This cosine graph, the purple one. Then flip the cosine, you get the secant, the green one. And then flip the sine, the black one, we get the cosecant. And then there's a tangent one, It's completely different shape. All of these are different shapes. In other words, I would say the sine cosines are the waves. The flipping U's are the secant cosecant, and these squiggles, I guess, these kind of curvy lines through the kind of crossing through the across the x-axis. Those are make me think of this cubic function a little bit, like x cubed, but they're not. But they are the tangent cotangent. Okay. Thank you so much, everyone. You have a great day, and tune in for the next lesson.